Okay, so let's take a quiz over what you've learned today. Question number 1, use the specific heat equation to answer the following. The same amount of heat is given to two different substances. Each substance has the same mass, but one has a higher specific heat. How will its temperature rise compared to the other substance? So what we're going to do is write down the specific heat equation 2 times. So let's say that Q is equal to C and then M and then delta T. And then over here, let's do it again. So Q is equal to C, M, and then delta T. So this was the specific heat equation, where this is the specific heat, the amount of mass, and then the change in temperature. So what does it say here? It says the same amount of heat is given to two substances, so that would mean that these two Q's are the same, so they'll be the same size, for example. And then each substance has the same mass, so notice the two M's are the same size. Okay, but one has a higher specific heat. So let's say that this one, instead of writing it as C, like this, let's put a big C. Okay, and then this one over here, this one is going to be a small c. So what does the delta t have to do in order to compensate? So it's like 4 is equal to 4 times 1, but it's also equal to 1 times 4. So if one number gets small, the other number gets big in order to compensate. So this one would have a small change in temperature, and then this one over here would have a large change in temperature. So that's how you do that question. Question number 2. What do the atoms of a solid do that makes the solid expand? So in the case of a solid, pretend that these are the atoms that are held together by electrical forces, which we could represent as springs. So as we add energy to the solid, it's going to start to vibrate. And so with a small amount of heat, then each of these atoms is going to be vibrating at a certain frequency, and it's going to have a certain amplitude. If we increase the energy that is going to this solid, then these amplitudes are going to get larger. Something like that. And if the amplitudes get larger, then what that does is it makes the solid expand. Question number 3. Explain what happens to the atoms in a solid as it turns into a gas. So as we continue to add energy to the solid, these amplitudes get larger and larger and larger until finally they break. So that's like stretching a rubber band too much. And as they break, then this solid breaks up into clumps of atoms that are still held together, but they are loosely held together so that they can roll over the tops of each other, and then that's going to be a liquid. If we continue to add energy, then all of those bonds break, and then you have a gas. And so the gas molecules or atoms then can basically go anywhere that they want. Question number 4. If heat has to go into a solid to melt that solid, then heat must do what when that solid freezes? So when it goes from a solid to a liquid, heat has to go in. So when it goes from a liquid back to a solid, what must happen? Heat must be given off. Conduction works the best in what kind of material? Is it solids, liquids, or gases? And the answer is going to be solids. So solids conduct the best. And then number 6, when heat is transferred in the form of electromagnetic waves, this is called what? It's being transferred in the form of radiation. Okay, so that concludes this lesson on how does heat affect materials, and then this also concludes this unit on the mechanical and thermal properties of materials. So that's pretty much it for my survey of physics. Now, if you want to stick around, it's going to take me a while, but my next project is going to be meteorology. So I'm going to try to come up with a meteorology course. So it might be a while before I start posting some more videos, but stay tuned. They are coming. And until then, see you.